Hello, so we'll be looking at some statistics from Algebra 2 and Trigonometry. So here we have the following table shows the number of gallons of gasoline needed to fill the car and number of miles driven since the previous time the tank was filled. So this is a given data. First they want us to draw the scatter plot. So how are we going to do it? I first put down the stat and we're going to go for edit. In fact, for this question, what I have done was I already placed the values into the calculator. L1 for gallons, L2 for miles, as you have seen over here. First, they want us to draw the scatter plot. So what I'm going to do is this. So let us say we're going to go for the draw the scatter plot. How are we going to do it? First, press second, y equals, and then we're going to go for number 1. We have to turn it on. We're going to turn on the first plot, and then x value was the L1 and y was L2. Now go for the zoom. If you go for number 9, then you will see zoom stat right over here. If you press that, then it will automatically plot those points for you right over here. So just if you're curious to see what these values are, if you just put down the window, then you will see that x mean started from 3.68 to x value. So this was our window for the scatter plot that was given in this way. Now when you look at this scatter plot, part B is the strong positive linear correlation or moderate or linear correlation. So in this case, when you look into that, if you have to draw the line, it looks like it's pretty strong, close by the given line. So therefore, there must be strong positive linear correlation. Now, if there's a strong, yes it is, then write an equation of the regression line. So how are we going to do it? First, go back to the calculator and stat calc and number 4 linreg, meaning linear regression. Now by default, L1 is the x value and L2 is the y value, but why don't we just type it in? And then press enter, then there it goes. So our equation seems to be, this one seems to be our equation. In other words, y equals 30.7136 x plus, if I were to just go up to here, for example, here in the all negative now, negative 4.1659. How about that? That seems to be the equation. Now, that's all we have to do. Now, that seems to be the equation of the coefficient of correlation. All right, let's move on to the next question. We got to do the same thing here. So what I'm going to do is this. I'm going to go back to the stat. And I'm going to erase all the values first. Alright, and then we're going to try to plug in these values. So 310, 210, 260, 330, 290, 320, 245, 293, 220, 260, 350. Alright, so it seems like we have 11 values here. So we have 11, 5, 11, 12, 14, oops, this was 12, 14, 16, 7, 10, 8, 8, 15. Alright, so it seems like we have all the values plugged in. Now, to find the scatter plot, so what we're going to be doing is this. Once again, step plot, plot on, alright. Just like what we wanted to do. Great, just to checking. Now zoom stat number 9. Then we'll see something like this. This is a bit scattered apart than the earlier one. So this we will say moderate positive correlation. Now if you wanted to find the equation of that, you'd have been going back to stat and then calc number 4. Press enter. There it goes. That's what we have. So here we have y equals 0.0653x plus, or maybe I should say minus 7.6812. Deriving the equation. Alright, let's move on to the next question. First, they want us to draw the scatter plot and coefficient of correlation to positive 1, negative 1, or negative 1, 0, or positive 1. We have to explain that and use the calculator to find the correlation coefficient for each set of data. So, in order for you to have a coefficient of correlation, we need to put the diagnostic on. So to do that, we're going to go for the catalog and we're going to type in D. If you keep on going, alright, diagnostic on. Okay, if you type in the diagnostic on in this way, press enter, then we will be able to see the coefficient of correlation. So just like before, let's put these values in. Stat, go up, clear, go up, clear. Alright, so we have 12.5 was the first, 3.4, oops, 12.5, and 3.4, 7.9, 9.0, 15.7, 7, 5.1, 11.9, oops, 9, 13, 10.7. Alright, let's look at the y value, then miles. 392, 137, 249, 308, 504, 204, 182, 377, 407, 304. Alright, so we want to do the scatter plot once again. So we're going to go for zoom step number 9. There it goes. That's our scatter plot. Coefficient of correlation seems to be positive one side. It's pretty strong. Let's actually use the calculator to calculate that. Go for stat, calc, number 4. Press enter. Then here you will see that R is the coefficient of correlation, which is 0.987 9. Pretty strong, close to 1. So that will be our answer. All right, let's move on to the next question. Here, we want to create a scatter plot, and we need to determine which regression model is the most appropriate for the data. And we'll justify the answer, and we need to find the equation. All right, so let's try to do that then. We're going to first put those values in. Here we have 4, 7, 3, 8, 6, 5, 6, 3, 9, 4.5. Oops. All right. So here we have 10, 7, 15, 9, 5, 6, 6, 14, 14, 8. All right, so let's try to see what kind of scatter plot we'll be getting. All right, so when you look into that, what does that remind you of? It looks more like a quadratic, isn't it? Do you see the parabola here? Then, why don't we try to look at the our calculation by looking quadratic regression. How about that? Why don't we try to go for number 5? And in this case, r squared ended up being 0.984. All right, let's go for cubic, which would be number 6. It should be actually stronger because higher the exponent and higher the degree, stronger you can get easily. So as you can see, that values are a bit stronger here. Now, just for the argument's sake, why don't we then go for quartic here. You see that this one is the strongest, as you can tell. Now, therefore, what is the equation of this quartic regression? Yeah, it's going to be somewhat tedious, but if you had to write up the equation, it would have been something like this. And then they want us to put it to the nearest 3 decimal places. All right. Then here we have y equals quarting, meaning what's the coefficient of x to the 4th power, right over here. So we have negative 0.008 a to the x to the 4th, and then b was plus 0.181 x to the 3rd, and x squared will be c, negative 0.512 x squared, and then third one is minus 6.613 x, and the last one will be plus 34.76 or 746. That becomes your answer. Now, let us move on to the next question. Here we wanna get the linear regression model. Find the appropriate value for y given x, and vice versa. All right, let's try to put this one into the calculator first. All right, so here we go. X values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 3.1, 3.6, 4, 4.5, 5.1, 5.6, 6, 6.5, 6.9, 7.5. All right, so we're gonna get the regression model. So stat calc number 4. This one gets us the equation right over here. All right, now given in this equation, let's try to go for the x value. When x equals 12, what will be the y values? So here we have, to put that into our graphing calculator. In fact, that's quite interesting the way we do it. So go for the VOS, statistics, so number 5. We want to get to the equation. We want to get the regression equation. Then it automatically puts them in for you. So if you have to graph them, you will see along the given values, that's the equation of the graph. Now, if you set the window, since we want to include the value 12 here for x, what we want to do here is you want to increase this one to maybe up to, how about 15, and then we'll graph it, and we'll just go for the value, calculate the value here. What if x equals 12? What kind of value would we end up getting? There it goes. So y value will be 8.44. That becomes our answer. Now, when y equals 140, what are we going to get? So what we like to do is, since y values are a bit greater than x values, what I'm going to do is I'm going to set the window y value up to maybe 150, just to include all the values. And then I'm going to go for zoom fit. Zoom fit is 0, so I'm just going to graph in that way. Now, then in this particular case, y2 will be 140. Then I should be able to see two lines intersecting. In fact, the window, okay, I have to increase the y value, I guess. So then, here we have I'm just going to put it down to 300. And then graph. Actually zoom fit. Right there. That will be the point where they'll be meeting. So I'm going to just go for second calc. An intersection, number 5. Guess. There it goes. X value where they meet up will be this value. So 282.67. That becomes our x value for y being 140. All right, let's continue. Same kind of question here. So and then we're gonna have same thing, 1, 2, 3, 4, 5, 6, 10. All right. Here, 0.8, 1.09, 1.25, 1.37, 1.46, 1.54, 1.6, 1.66, 1.71, 1.75. Alright, so that's what we have. Similarly, as before, first we're gonna zoom stat, which is number 9. That's the value that we'll be getting. Now, when you look onto this one doesn't look like the linear regression. It's more like a logarithmic regression. But if you have to remember the question, it says determine the appropriate linear regression model. So in fact, I guess what we have to do is we still have to use the linear regression model here. If they were to give us the option to use the logarithmic, then we would have used something else. But for now, we're just going to use linear regression here. Actually, this one is number 6, so it's not part of this one. So in this case, why don't I simply use the logarithmic? Only because it looks so much like logarithmic function. All right. So that's the value that we end up getting. Now, just to show you that the if you had to go for y equals, I'm going to clear this one, both cases, and I'm going to pull out the regression equation. Oops, number 5. And then graph it, and you will see that it very closely it matches it. So therefore, I'm going to be using this equation. When x equals 1.4, it is between these two values. So to calculate that, if I were to go for value, x has to be 1.4. And as you can see, y value will be 0.938. How about y equals 1.4 and 1.50? Then I'm gonna move on to the second, 1.5. When I graph them, I'll see the intersection here. So I'll use that to calculate number 5. First curve, second curve. Guess. Alright, there it goes. When y equals 1.5, x value has to be equal to 5.457 or 458. Alright, that's it. I'll see you later. Bye bye.